Welcome to the Edifice Complex, the Property Design and Development Podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague, official agitator, friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, sir.
Hello there. Right, interesting one today, right? We are, is this the Elon Musk I've been looking for? We shall find out, right?
Maybe. Yeah, so today's guest hails from the farmland of Iowa, where he specialized in the art of breaking and fixing things. And so what does a farm boy do when there's nothing left to break or fix? Well, the reality on a farm, everything's always breaking and you need to fix it. Well, he went on to earn a Bachelor of Mechanical Engineering from University of Iowa, and then also went on to get his master's in environmental engineering, and then a Doctor of Science, Building Systems from EHT Zurich. Today, he is the founder, director of K.S. Labs at Princeton University, director of PhD in Computation and Energy in the School of Architecture, father, inventor, and bicycle mechanic, which I love. He's one of the few that understands Exergy, so already we're happy to have him on. And the importance of second law thermodynamics. I had somebody review a paper the other day, and we used the word Exergy, and they said, stop using jargon. Just like, oh, really? We're at that stage? Anyway, he wants to change how we measure and control people's thermal relationship with their spaces. Welcome to the show, Forrest Meggers.
Thank you, Robert. Thank you, Adam. Super happy to be here.
Yeah, so I'm standing here right now playing with one of your toys. We're gonna take this on the road, actually. Really, I think it's the next generation of sensors. We were going to talk a little bit about this, but first, before we get into that, in between you being up in the farmland of Iowa and then earning your PhD, you had a huge story to tell. So why don't you give us the short strokes?
Yeah, well, it took me a long time to realize that it was breaking things that I learned everything from. And a quote that I used at Penn that now one of my colleagues there constantly refers back to is I was trying to explain this, what's the short version of the story, and it's basically that everything that I know, I learned in college, but everything that I do, I learned as a bike mechanic. Because it's really like the troubleshooting thing is a skill you don't teach, and just being really good at troubleshooting turns out to be pretty good when you're trying to fix broken things. And it turns out the built environment is pretty broken. There's a lot of things that are like, hey, if I stare at this long enough, I kind of realize we're doing it wrong. We should probably try a different way. Let me see if I can measure or determine what really is going on here. So yeah, that's the short version. I mean, the longer version is a bit more of a, one of those cascades of dominoes where it's like, I'm in Iowa, and then maybe I'll go work for the climate change folks in New York for a month, and then I'll end up in Switzerland at the ETH and do some research for a book project, and maybe I'll stay and do my PhD if my wife comes there too and does one too. And that all kind of fell together, and then ended up there for 6 years, and then Singapore for a couple years after that doing a postdoc. And I sort of joked that it was because I needed to go to like the cold mountains and then the hot, humid Singapore so I could come back to New Jersey where we have both of those things. Cold winters, very hot, humid summers.
Yeah, it's like I think that's kind of like Winnipeg, Manitoba. I think it's one of the only places in the world where it goes from minus 40 to plus 40 C.
Exactly. Yeah.
in 12 months, right?
Yeah. Well,
so anyways, keep going.
Exactly. No. And I always joke that Iowa is even worse than all of them, right? We get the whole swing. The middle of the continent, you get the full continental temperature swings. So maybe that's why I ended up eventually arriving back at thermal comfort most recently, right? So all my PhD work was around Exergy and heat pump efficiency and coefficients of performance, and kind of obsessing about the system side of things. And it's more recently with the sensors that you were just holding up, kind of that we're realizing that making the machines efficient is really important, but understanding the human side of it is actually kind of a harder problem, but one that's more fun to engage in as an adult, philosophically. As a nerdy college student, all the equations were fun, and now I'm sort of rethinking how you challenge a lot of the paradigms instead. And I think on the comfort side, there's a lot more interesting ways to put together arguments for doing things differently that don't necessarily involve only engineers redesigning the system side efficiencies, which is still important. Not to say that I don't still love Exergy.
All right, just there's so many places to go here, but I do want to talk about the comfort thing, right? So I saw you there was an article about you in the New York Times about, was it My Never Ending Basement Project?
Yeah.
Great headline. But what was that about? Because there's a hierarchy in property development, right? And let's face it, residential is the bottom of the bucket. Mm-hmm. No one cares about it. You know why? Because you don't have to, because you could build any old piece of crap and people will buy it. This is the problem, right? Home ownership is a cult in the Anglosphere. It really is. So what was that article about? And is your basement project finished, I guess?
Well, it's the whole house project. And I mean, that does go back to the definitely breaking things, because the broken thing was not so much my house as it was when you live in sort of Princeton, which is the sort of classical suburbia. Yeah. You just watch buildings get torn down and replaced by these terrible McMansions that are built. So like it's so like the frosting, like the pretty frosting on the outside of the cake that's made out of crap. Yeah. Oh my God, it's so bad. And as someone who understands the building so intimately, not just because of the, studying architecture and building systems, that actually doesn't help you do the forensic part. The forensic part came from, number one, the bike mechanic, but number two, more importantly, that my dad built our house my whole child. I mean, growing up on a farm, you're always building all this stuff. So seeing it go together badly is very painful. So I really wanted to test out some of the technology from the lab in my house, but also to rebuild my house the way I wanted it. And it was kind of a pent up thing too, because this whole academic 10-year process. And so then the house reconstruction was really the culmination of sitting in my house, wanting to change it in ways to show people how much better you could do it than the McMansion version, and having to wait 6 years to even start thinking about it. And then finally being able to do it, I really kind of went whole hog. And the kind of funny, not so funny part was, I was unfortunate enough to get run over by a car on my bicycle, which then landed $300,000 in my pocket. And so then all of a sudden I had the money to do it too. So it was this series of unfortunate events that enabled me to sort of do all the things I wanted to do. That being said, I mean, you can take a loan out for that. That's like a small fraction of East Coast house costs, but not an insignificant amount, but it also allowed me to kind of do it in the way I wanted to do it. And a lot of people don't realize, although there's a lot of rules on the East Coast, I was surprised to find out that in New Jersey, I was allowed to do everything: the electrical, the plumbing, the construction, the carpentry.
It's the home of Tony Soprano. Of course you were allowed to do that, right?
Exactly. Well, I thought I was going to have to pay someone off along the
way. Joey, don't come after you.
I mean, truth be told, a lot of the heating system has not been inspected because I keep rebuilding it, because that is sort of the most prototypey part. I mean,
all right. So I've got to double click on this, man. I've always had this fantasy of my lakeside house, radiant heating and cooling, proper ventilation control, managing the CO2 levels and radon levels. And then I look at the permitting process. Getting anything done in Canada, it's like shitting an elephant. It's just, you get to the point where I can't do it. But you did it, right? So you've achieved my fantasy.
It took a lot of my Iowa nice gene, right? That's the having worked with my dad, the carpenter, you learn how to talk to people who are carpenters, which happens, and plumbers and tradesmen, and those are the inspectors too. The people that have the job that come and sign off on all the stuff are basically my dad. And so I just would hang out with these guys and be like, oh yeah, and then you always tell them they know how to do it better than you, and that, oh, tell me what I did wrong, because they're used to inspecting stuff where it's contractors that are trying to hit a bottom line and do it the cheapest. And when you're a DIYer, they love you because you're like, I'll do whatever you say to So the sort of the rapport part is, I think, one of the less appreciated aspects of DIYing a house project, is that it's actually easier to interface with the inspectors, even though you have to get the permits signed off and you have to do cover inspection and everything. You just call them and then they come, and it's a weirdly analog process in these days of digitalization. The only time I have to pick up the phone and call the office, tell the guy to come, check out my wiring, tell me how I used the wrong size electrical boxes, and
So you say, I want you there at 9. He says, I'll be there at 3. Have a cup of tea for me, right?
Yeah, exactly. Yeah.
I mean, for our listeners, what you should be observing here, because this isn't a normal conversation with somebody who's from Princeton with their doctorate degree. And that's what makes you unique, Forrest, is that you've been, on both ends of the bookends, from doing hands-on stuff to the academic stuff. And that's hugely valuable. Adam and I have talked about this before when I had my engineering company and some of the other businesses that I've had. We would hire people out of university, and the people that always got the nod were those that came from the farm because they knew how to fix shit.
There you go.
And they could think on their feet, right? You didn't have to teach them how to think. Or those that were during the summertime that they were doing stuff, either working in construction, even we would look at, and that was one of our filters actually, is what'd you do in high school? Like, tell me how you earned a living in high school. Kids that were delivering papers or whatever, like they always got the nod. We didn't care about the
intern
just have no work experience.
But how's the house performing it? Now you sort of like got it done. Is it performing as you thought it would?
Well, I mean, one of the parts that I worked on at the university over the last 10 years was putting in this massive geo-exchange system. So we have over 1,000 boreholes on campus, but that was also in part because I was planning to do that with my house and doing it sort of simultaneously. So I sort of joke that the university just copied my house, having like storage tanks, geothermal, water-to-water heat pump. Water's way easier to work for. I always have this. Water's 4,000 times more dense than air, so why do we blow air around everywhere in all these ducts? And
thank you for saying that. That's always my thing. Pipe can transmit a lot of cooling, right?
We're going to get our video editor to repeat what you just said over and over again.
Yeah, exactly.
Like, tick, tick.
I should go. The thing I do, I've taken now like over 200 students through my house in classes from the university. They drive over in the university's fancy electric buses, and then the first thing I show them in the basement is like, there's this little like 0.5 meter by 1 meter box that is now the heat pump. And then I show them, this is the whole corner of the basement where the furnace and all the ducts used to sit. And I always like have a picture of the Home Alone basement when he walks down, the gigantic thing that it takes to blow air everywhere in your house and how silly it is. And so
shout out to Forrest Meggers' wife. Like, holy cow! She should get an award. Really, like Forrest.
We did live a whole winter with just the wood stove in the year between the two things when I had ripped out the whole downstairs, but just put the wood stove in, and it worked well. I mean, that's what I grew up with too on the farm. Wood stove was 90% of our heat.
Yeah,
housing is ultimately a cultural phenomenon, right?
Yeah.
So, I did a project this is years ago when I had a practice, and we went radiant heating and cooling, like DOS, like low velocity ventilation, like displacement ventilation. And the complaint we had was it was too quiet because people associate being comfortable with having air blown on them. So how do you find that in the house? Like you obviously got a lot of air being blown around, right?
Yeah, no air being blown around. Lots of really quiet ceiling fans. Every room has a ceiling fan, but even those are quiet. But I've strategically poorly installed them, as all DIYers do. So they go fast, they make noise. But other than that, you're totally right. I think the most famous story I have about that is actually the National Renewable Energy Lab, which is now the Rocky Mountain, whatever Trump.
Oh yeah, Rocky Mountain Institute. Yeah.
They renamed the National Renewable Energy Lab to like the National Lab of the Rockies, I think, because you can't have a national lab with the word renewable energy in it anymore, apparently.
Really?
Yeah. Another sad story from the U.S. But let's put that aside. The funny story that's related to the built environment is that they built a building that was all exactly what you said, a huge building, and they actually had to install white noise machines that made the sound of air moving everywhere.
That's what we had to do on that project
office.
In the end. We got so many complaints.
It's so quiet that people were like, we need more noise, like background white noise.
Yeah. Is that the building in Boulder?
Yeah, that's, it's outside of, what's the name of the town where Coors is? Golden.
Oh, okay.
Yeah.
Oh, okay. That's the RSF building. Okay.
Yeah, it's a pretty big research campus.
Yeah.
RMI has their snowmass office, which Amory Levin's always like, if you were talking to him, he's like, this is how many bananas I grew this year. It's fantastic. But they also now have a new building in Boulder, like a bigger RMI office.
I suppose
Avery's
that's
got a great story. I think he was it Oxford that changed the rules to let him come in as a researcher.
Probably. He's such
And then I think 6 years later he told them to take their fellowship and stuff
yeah.
it.
that's a baller move, right? That's a baller
Yeah.
move.
Yeah. He bought the sensor from me for the cheapest amount of money because he was in the lab and was like, he's doing the radiant stuff now with the sky cooling guys at Stanford.
Right.
Yeah.
I was like, I have this sensor that measures radiant. He just slapped $200 bills on the table and is like, give me one. I'm like, well, usually I sell them for a little more than $200, but okay, Avery, you can have one.
So let's talk about that. Let's talk about your sensor again. What do we call this thing?
The Comfort Cube.
Yeah, Comfort Cube.
Yeah,
Right, we
it's
need to
Comfort
get
Cube.
Don
Although
Draper to work
There's
on
a
that.
longer trajectory. I mean, this started way back in the very first prototype that I built at Princeton back in 2014, which was this, what we named the Thermohelio in honor of the Olgier brothers who were in 1950 at Princeton, which I didn't know when I came to Princeton. Everybody told me Princeton School of Architecture was nothing but a bunch of history and theory people. But then it turns out that there was all this like building science stuff that happened from the 50s through the 70s, basically, starting with the Olgiers, and then Rob Sokolow actually wrote the first issues of Energy in Buildings, which is the journal that I published most of my papers in. Les Norford did his PhD with him here, who's at MIT and I work with. So there was a weird building science history, including the dean of the Berkeley School of Architecture that renamed it the Environmental School of Design or whatever, Harrison Fraker, who added all these crazy buoyancy flow things to architecture building. So it was this weird like institutional memory that was missing at Princeton that I had to go rediscover. And so then we built these prototypes around doing radiant heating and cooling, which the Olgiers in the 50s were kind of obsessed about. And then their book went out of print and we got Design with Climate republished in 2013. And in that project, we were trying to figure out how to measure the radiant part. And we kept putting the globe in it, but if you try and use globes outside to measure the long wave, like the not solar part of the thermal radiation, which is usually only a few degrees of change in what we call the mean radiant temperature, right? So if I do like a radiant surface outside, I might be able to change the MRT by a few degrees. If I put you in the sun, it's the equivalent of being in a 50 degrees Celsius box. If every surface is 50 degrees Celsius, that's the same energy as if you stand under the direct sun. So I always like to kind of equate the long wave, like infrared that you don't see, like, or that the energy that is not visible to you, but is there with the sun to give people like, everybody has an intuition that if you stand in the sun, you feel warm, but most people don't have as much intuition that also surfaces that are hotter or colder significantly affect the heat that your body is losing and the heat that you're experiencing and whether you feel hot or cold. And the reason we don't have intuition for that is more, I would argue, an anthropological one or a social one, in that we as humans have trained ourselves to look at bank clocks, to look at the thermostat, to listen to the weatherman who only tells us temperature values about air temperature. And we kind of walk through our universe with this false pretext that everything is only based on air temperatures. But then the problem was when you start to build prototypes, you'd be like, hey, I want to cool people with these radiantly cold surfaces. And I wanted to do it outside because I thought that was kind of fun and novel, because it's really hard to do air conditioning outside because for some reason air doesn't stay in the same place when you don't have a
What?
Yeah, I don't know why.
Shocker.
But it's also a good way to point to why all our buildings like seemingly have to be enclosed boxes. But it was more of a fun sort of exploration, because that was the nice part about being not just in the engineering school, but appointed in the architecture school. So I could do a little more non-standard testing of things. So we built this big dome that had radiantly cooled surfaces, and we put the globe in it, and it was only measuring that it was a little bit cooler. The radiant temperature is a little cooler. And it took us a while to realize that the device tried to measure the radiant part. As soon as it gets cold, then all that warm outside air starts heating back up the globe again. And the correlation is you have to do this correction with these devices. So the globe is just this generic, like 6-inch sphere, which was a really clever way to measure in analog the radiant heat that happens to a surface in a space. And to be honest, the original version that was built in 1930 had a sister component, which was a silver globe. And if you have the sister component, then the silver globe does not exchange any radiant heat because the silver surface is non-emissive.
Emissivity.
So it does not, it has no emissivity, so it doesn't exchange with the around it. And so the really clever thing that they did was the original version, you'd have a globe And in my space, the globe would have gotten colder, but then you'd take that little, and even they did this in analog, which is the coolest part. Is everything I do now is just digital sensors, but in analog, they would measure the temperature in the globe. Then they'd use a really clever little resistance heater and heat the silver globe up so that it would, or cool it down, but I guess you couldn't do it electrically. So they usually do this for heating environments, right? You put the globe in, it gets warmer than the air around it. Then you put a little heater to make the silver globe get the same amount warmer. And then the really neat thing is the energy it takes to make the silver globe stay as warm as the black globe, right? So now the silver globe is warmer and it's not getting the radiant heat to keep it warm.
Yeah.
So all the energy that it's losing to stay warm is exactly the convective exchange.
So they
then you
balance
have
each
both
other out.
components. Yeah, so you get both of the components. It's very, very clever. But that whole
somebody
system, obviously,
They
hard
forgot
set up.
to they forgot to pass that on.
Yeah. Well, what they did was it's really hard to build that. And so if you're a good scientist, you make a correlation for what the air movement is and what the silver globe says. And very quickly, they just got rid of the silver globe and used the correlation for the black globe. And so you just would edit the value based on the air movement. But remember, that was all made in a time where thermal comfort as a word did not exist, because this is the 1930s. So that was all published in a journal called the Journal of Industrial Hygiene, which was basically like, how do we keep people from dying in the really hot factories that we built, where you have to work next to giant steel melting machines, and it's like mean radiant temperatures that are 30 degrees warmer than the air temperature. So it's a very different context for the amount of air in that system. But then as we move to today, right now, thermal comfort is a thing where even 1 or 2 degrees of variation in MRT are significant to whether people are feeling too hot or too cold. But the globe thermometer now, the sensitivity to that air movement and those correlations actually fail to be able to capture then those variations of 1 or 2 degrees. As soon as the air starts moving in any significant amount, your MRT becomes completely washed away by all the air movement measurements that you should be making. So in the end, this is a much longer story than you probably needed, but hopefully everybody has some fun, nerdy science history. Now we have this new device, the Comfort Cube, which was an evolution of things that we built using contemporary thermopile sensors that when you point them at a surface, they give you the surface temperature. And they're made by filtering out all the visible light and isolating the exchange of the long wave between a surface and a detector. And then the detector can be calibrated to understand the surface temperature. And this is what's happening in every pixel of a thermal camera. So most people are probably more familiar with the image behind me, right, of a bunch of really warm people.
Yeah.
So every pixel in the camera of that has a germanium lens that filters out all of the shortwave energy, and then only the long wave energy, the infrared energy, for which we are all emitting, which is another sort of fun philosophical way to think about energy, is that all the yellow heads in the screen behind me, the light that is being shown there is actually light coming from their atoms, versus the visible light that we see of each other in the podcast is actually just light bouncing off of us.
Yeah.
So from an energy standpoint, like looking at a thermal camera is kind of this fun window into the energy you're actually emitting. All the people in the image behind me are little suns pushing out energy. And so understanding that energy exchange is why those tools that we use to measure that infrared environment are actually really valuable. So being able to do that with a thermal camera is good for the image behind me, but in order to get the heat transfer to you guys in your space and understand the comfort in all these prototypes that we've built over the years, we needed a really robust way to calculate everything around me in a 360-degree sphere. So we built a lot of versions of these that at one point were all on gimbals. They'd rotate and take pictures. But in the end, then we used, and in part thanks to sort of COVID making those little remote forehead temperature checkers very common, the sort of core technology is the same. The things that are on every face of the cube, the Comfort Cube that Robert has, are the detectors that measure the long wave. But that's not to say that the short wave part, the visible spectrum, does not also have energy. Your black shirt is absorbing heat too. And so the little white discs on the Comfort Cube measure the shortwave component too. So we're trying to capture all of that radiant environment in order to characterize the thermal experience, which for the indoors case is usually about 90% exchanges in the long wave part. But as soon as you go outside and you have the sun and the bright sky, that shortwave part becomes very important.
So
But we call
Forrest,
it, but we call it
Forrest,
the comfort cube because it measures all the parts. So
yeah.
well, it's not just radiation. There's other things. Yeah.
Okay, so take a breath.
Yes. Sorry.
so, I want to bring up for our audience why this discussion is important, and the picture you have in the background is a great segue into what I'm going to say. There is a segment in the industry, particularly in academia, that is making arguments on inadequate data that the MRT equals the air temperature. So they're saying that for most spaces, unless there's some unique thing going on, like an exterior wall, window wall ratio, blah blah blah, they're saying MRT is equal to the air temperature. In fact, there was a paper within the last month. We're here in April of 2026, came out making that statement. And it was from somebody who was doing a study on a lecture hall. And they made the statement, air temperature equals MRT. And then I'm looking, and what you have behind you is all these little orbs of energy. And I said, how is that possible that the air temperature could be the same as the MRT when all around you are these other students that are at, whatever, 86, if we're working in Fahrenheit, right? And so it's not possible that the MRT could be the same as the air temperature. So why, we could go a whole bunch of different places here. Why, when you go back into the late, say the 18th century, early 19th century, where we had actually probably better understanding, I would say, documented understanding of the indoor environment, and then something happened, and I think it probably was the introduction of air-based systems in America. People need to know that are listening to this, the audience or listening to the podcast, America is not, and I'm going to say America, I'm talking about Canada, the United States, Mexico. In other parts of the world, like Korea, for example, radiant heating and cooling is like 98% of the marketplace. Like every building has it. You go to Europe, it's the same thing. We are the anomaly. We are not the norm. And our population maybe represents 4 or 5% of the total global population. So our lens is not the same as the global lens when it comes to comfort. So anyways, going back into time, something happened where we've ignored the science. And I think that had a lot to do with, we know all the big brand names that exist today, the trains, the carriers, the Lennoxes, you just go through the list. They dominate the marketplace.
Exactly.
And so we have today, 2026, where we're struggling, not only in terms of academics, but also in terms of our practitioners to get people to understand the relationship that people have. And that's why I think these types of devices, the sensor cube, let me get this in front of here. We can specify it, we can model it, and now we can measure it.
Exactly.
I want to know from your perspective, how do we break what's broke? How do we re-break, break the marketplace?
Unbreaking. Well, and I mean, this also answers we were talking earlier just about how do we get students excited about going into building sciences again, right? That's kind of, it's the same. The answer is the same for both fields, both in terms of the practitioners and the students. Is we kind of have to bring back a certain level of agency in the creative generation of ideas for how we heat and cool spaces and people, and maybe not heat spaces and cool spaces as much as we heat and cool people. And because we really don't even think about how the person is related to a space. Right now, every single MEP firm and every single HVAC technician, all the calculations that they're doing for sizing and installation of all of their systems only have to do with getting rooms to, in the residential side, like the code temperature they need to hit. And there's forms in the US and Canada that everybody uses, these schedule, I'm blanking on the number, but you do a form and you figure out how big your Lennox furnace needs to be in your
the manual J.
Manual J, thank you.
Yeah.
But then even on the MEP side for Arup doing, big buildings on Princeton's campus, they're still just trying to get rooms to a certain code level temperature, and they may have a little bit more obligation to figure out how they do that efficiently, but there's no human in any of those calculations. And it's all predicated on some end goal of being able to make the room like 68 degrees Fahrenheit. So like making it like 20 degrees Celsius on the hottest day of the year and being able to make it like 75 or like 26 degrees on the coldest day. And the whole system is focused on making sure that you do those worst case scenarios, and there's no penalty for oversizing anything. So we have a whole universe of oversized equipment and equipment that then only turns on once in a while. And the poor soul who has a human body that happens to be underneath a diffuser, blowing the cold air, the hot air, and even on the air side, although I always say like the problem is the air mixes and you don't have very much variation. You do if you're sitting under the diffuser. And I mean, I think all your listeners, I mean, all the listeners know this. This is a classic one I use all the time. You're like, oh yeah, I've been that person. And then people will always comment on, wearing jackets indoors in Singapore, or even in the summer here in New Jersey, just like buildings being overcooled, and likewise on the heating side. And facilities at Princeton, they have like posters that say we set the thermostat to, 75 in the summer and we set it to 68 in the winter, but you walk around with my sensor and then you're like, oh, actually, no, all the systems are still pretty oversized. So even when you're trying to hit set points, things like minimum airflow volumes into spaces will overcool spaces, even though without hitting set points. There's other issues that are kind of embedded in the way the systems are deployed. And I would argue, go back to the original question, Robert, is that if there was a little more creativity and a little more design agency embedded in the process of making heating and cooling systems, rather than it being this formulaic sort of cookie cutter thing, that would be, I think, the pathway to change. And in order for that to happen, there has to be buy-in, unfortunately, or fortunately, I guess. But as an engineer, sometimes you have to pick on the architects. But like the architects, they're the ones that are like supposed to be the creative ones. We'll put it in quotes. But I mean, there is novelty to what they do, and there is appreciation of that novelty. On the engineering side, like I would argue structural engineers, like, they get a little bit of it, right? So like formally and tectonically in building making, like you can do some pretty crazy structural things to like make novel massing and forms be created. And that has never happened on the heating and cooling side. And we can definitely do more novel and interesting things with heating and cooling systems that then can be driven by the experiential part of it that people want to pay for, instead of just trying to constantly convince someone to do something based on the bottom line dollar and cents. Like, my heating system is the most efficient. I think that's the biggest thing that we shoot ourselves in the foot is,
Totally.
fortunately, only talking about Exergy, which I love to do. That will definitely make your system the most Exergy efficient. There is a whole calculation we can do, which I've also written papers on, around the human body Exergy consumption, where you can also optimize how heat gets from the terminal units and the radiant surfaces and the ceiling fans, and how the relationship between your body dissipating heat and those mechanisms can also be made to be more Exergy efficient too, the more effective way for your body to get heat away from it.
Yeah.
So just on, there's in the late 90s, again, I'm old as hell, right? In the late 90s, outside of North America, I can give you a whole 2 hours where you never put a VAB system in. That bullshit, right?
Yeah.
But what you can do is what they do in every other part of the world, apart from North America, is an outside air reset. If outside, I'm speaking in centigrade here, right? If outside is 40 degrees C, you can let inside drift up to 25, 26. And everyone is like, okay. I've never seen an outside air reset control loop anywhere in North America, right? It's just like 21, like 50 degrees, 50% RH. What is that about?
Yeah, no, and then the whole, I think that in part helped to drive some of the adaptive thermal comfort model, where you're trying to at least change the standard in the background, or like to get people to shift what they expect, at least based on the climate outside. So I mean, that's an expectation thing that then is also being ignored on the control side of the universe. Although I can have a whole other diatribe about the controls, like why controls are bad is it's an interesting moment now, because you should do a separate, I can give you some people to do the AI podcast on controls, because controls are still done in these control integrator languages that are not computer science languages. And so it slowly changes. It's going to be a weird moment when like smart people like us all of a sudden have access. Right now, you and I we can't go in and write the outside air reset because it's going to be in some weird proprietary Siemens coding language. It's going to be buried.
Klingon.
It's going to be in some stupid PLC. It's not even going to be at the supervisory control level. It's going to be buried there. So you're not going to really put the outside air because the outside air is like going in as a point on a PLC that you have to change the control loop like at the PLC level. And who's going to do that? You have to pay your service contract $100 million to come in and fix your outside air research thing that should be running and is super simple. And so I think the control side actually has this, I think it's on a precipice personally. Like it's all, the ship is on fire and they know they need to change. And I think it's coming soon. Like all the little controls companies are like, have Python integrations. The big ones are all still hanging on for dear life with their proprietary crap. And so maybe you and I will be able to change some of that soon. And hopefully, like, that's why, I mean, the Comfort Cube thing, Robert, hopefully we can just pop that into the control system. I just sent Robert an app that I am not a programmer, and I just had Claude make me an app to read the device. And previously you had to have Python. And I'm like, can you make one that will just open on a PC for my friend Robert? And it made it. So there's like the ability to make interfaces and controls work is like,
that's interesting. Like when people come and say to me, I want a smart building, my answer is you have one. You've got VAS, you're just not using it, right?
Yeah, exactly.
The data, who owns it, and it's all proprietary. If we can get past that, that changes everything, in my opinion.
Yeah.
But what it does do, right? Let's say there is this clarity that comes, like these clouds part and we all see what's going on. Then owners are faced with doing something, right? You know, it's like, give me a LEED Gold building. What does that mean, right? And then all of a sudden, there's a contract with Arup. Let's just pick on them because I'm ex-Arup, right? And they do it to their standard, right? Then all of a sudden, technology enables the owner to see what's really going on. It's like, someone's going to get sued here, right? And that's what it's going to take. Someone's going to get sued out of existence, and that's the reset. Would you agree with that?
Yeah.
Oh, yeah. No, I mean, Siemens is getting sued. I know of lawsuits, yes.
The Edifice Complex will continue in just a moment.
Are you struggling with paperwork, spreadsheet overload, and project management? Then Blue Rhythm is the solution to help you. Streamline your commissioning and project management process. Go paperless, increase efficiency, and save money. Blue Rhythm is commissioning and project management software by practitioners for practitioners, adapting to your workflows and processes, and doing things your way. Blue Rhythm provides painless and fast onboarding by bringing your existing workflows, forms, checklists, and issues logs into Blue Rhythm for you. You can use their pre-built templates to customize your commissioning workflows. And Blue Rhythm can fully handle the transition from your current software platform. Blue Rhythm is secure, scalable, and reliable, backed by amazing support, and accessible 24/7 on any Windows, iOS, or Android device. Why are you still using paper and hard-to-control spreadsheets? Start your free Blue Rhythm account today at bluerhythm.com.
And now, back to the show.
Do you know Zoltan Nagy?
Yeah. He's a good friend. We
had him on the show. I love the guy, right?
Yeah.
And June Park, and they wrote, and this again for our listeners, they did a literature review over 5,300 papers, and trying to find the correlation between BAS systems, BMS systems, building automation systems, and the word thermal comfort, and it was completely disconnected. Out of 5,336 papers, whatever it was, thermal comfort was like a footnote in the control papers. Like there's just no connection between what the building controls are supposed to do and what people are expecting it. It's our place that we operate in.
Yeah, exactly. And Zoltan and I have had a lot of conversations about this controls problem as well as Adam Rieseneck at UBC and Clayton Miller, who's in Singapore. We've been going back and forth about the data side is one, like how you store the data from is done very poorly. So there's like you could be doing better post analysis of things to understand what's going on. And then there's the whole controls front end, which is all in these proprietary controls integrators buried in like JACEs and PLCs that are technically Windows 95 machine level processors. But they're that for like a good reason. Like in the 1950s, when we made controllers, we had to make circuits that would run for 20 years and be super robust. And we just never stopped doing that, even though if I take 5 shitty Raspberry Pis and run them in parallel, they cost 1/10 of the PLC and they will fail 1/1000th. Like the probability that 5 fail at the same time is 0, basically.
Yeah.
Right? But we haven't shifted, like that's called distributed systems. So we haven't shifted to that. That's something Zoltan also knows more about than me. But there's all things like that. But what I wanted to comment on, which I think, Adam, you were saying earlier about how the residential, nobody cares about the residential sector. The funny thing about the Nest is for me in developing the sensor, it's my most important case study because 20 years ago, if you went to Best Buy or whatever electronics store, there was no thermostats. Now, if you even go to Target, there's a thermostat aisle.
True.
Right?
Yes.
And so now all of a sudden it's a consumer product. So like, thanks Google for doing that at least. Now it's not the pariah of HCI. So human computer interaction is a whole field, right? And it's more about the interfaces. And so if you would study that and you weren't a building scientist, if you just went to Princeton Computer Science and you took a class on HCI, day one, they'd be like, so here's what human computer interaction is. This is a thermostat. This is the worst HCI ever done in the history of devices, the 1970s programmable thermostat. And they would literally show you, you have to press a button 137 times in order to program this thing to actually have the temperature setbacks.
Yep.
So the Nest thing, although terrible on the thermal comfort, it only still measures like air temperature.
Yeah.
And it took forever for them to even have like room level sensors that you can use with it. Ecobee, I would argue, I liked that. Ecobee is a much neater company. They had the idea first technically, but it was a Google guy that made it really popular. There's the Ecobee remote sensor, exactly.
Yeah.
So like having even just remote zone temperatures is super easy. And so the interesting moment that we're in now is, unlike commercial buildings and controls that are still stuck with all these contracts with Siemens and Johnson Controls and Trane, etc., the residential market is like, they are only beholden to what Amazon will sell them. And right now I can order air quality sensors that integrate with Amazon and Google and Apple, and I can order temperature and humidity sensors, and all those things come out of the box saying works with Google, works with Apple, works with Alexa. And so the weird thing is that by accident, the residential market has become the smart system market. And if you go to like Home Advisor, or there's a bunch of these open source home assistant setups that you put a Raspberry Pi, and if you're pretty nerdy, you can build a very, very smart building, right? So I had a student for my house, I wanted to automate all the window openings. So I was building little stepper motor controllers to open and close my windows so that I was very anal and made all my casement windows open in the windward direction. So I had the whole flow field that goes around my house. But even if you open all your windows the right way, it still rains sometimes. And I'm like, I'd like it to open when I'm not there too. And you can do that with these systems. You just put a little device, and I can take this little controller, the little brains inside my sensor, and it can do all those things. And now the weirdest moment that is like today, as of a month ago, I realized that I can now program all that stuff. I used to not have time to learn the Python that I need to program every different thing I wanted to do. But now that's really where the AI, the large language models like Claude and ChatGPT, I made, again, Robert, this app that I never would ever have been able to make anybody an app for my sensor. I'm really good at building the hardware and knowing the physics, but like coding dashboards and making computer interfaces is just not a skill I ever had. But it turns out that's one of the peoples that are being replaced right now by AI are the people that coded like websites and dashboards and stuff. You just tell it what you want.
By the way, Forrest, I have to explain to my girlfriend that I have to, instead of going skiing today, I have to upload that new app.
I think you're set up just fine. You can try it. If it doesn't work, it's the beta version.
I just want to double click on something you said here. That was a real insight, actually, that I personally hadn't latched onto. I sort of instinctively knew it was there, but didn't think about it. One, I think you might be king of the nerds, so congrats on that. But two, you talked about distributed control versus centralized control, right? And this is what we're talking about here, right? Is like moving control down to the lowest common denominators and then sort of networking them, right? Which is actually fascinating. I never thought of it that way. That is a really interesting distinction.
And so much
And
easier to get redundancy at the controller level then.
yeah, one goes away. It's not the end of the world, right? Because you think like, at the moment, my house, typical North American house, got one thermostat for the whole house, right?
Yeah.
It's not even averaging like at different levels.
Yeah. Yeah, exactly.
Yeah, that is a really interesting thing. So if you're Honeywell or Johnson's, you're going to fight decentralization with every ounce of your might.
They're not going to. It's a past tense. They have been fighting it. Yeah, they've been buying up and getting rid of like little companies that keep trying to start up. Yeah. It's but I mean, they're not so worried about the residential market, so that's kind of where it's happening a little bit on the side. But there again is sort of an North American problem of a lack of appreciation for trade and craft. So like the poor HVAC guys that go around, like, you know, sadly, many of my Princeton colleagues would say these people that never went to college and work as HVAC technicians, you know, too bad for them. They, you know, didn't get to have the success that I had going to meetings all the time at the university. Meanwhile, these guys are making $300,000 a year, you know, shuffling Linux furnaces off their trucks during the day. And in the end, like, they should be proud of what they do. And they are a skill that's hard to find. I'm friends with all the facilities HVAC guys. And I mean, Princeton wants to hire the best HVAC guys, and they struggle to find people that are good. Because I mean, we're building these pretty complicated heat pump. You know, we have 5 megawatt heat pumps going in over 1,000 boreholes and all these things. And they need people that know how big machines work. But we also have little, you know, evaporative. We have every version of heating and cooling systems. And so.
And you need systems integrators, right? Which is what like the commissioning people are.
Exactly. Yeah. But then like, the HVAC people, unfortunately, they're the ones that are the most resistant in the residential space. Like they hate the Nest thermostat, right? It's so annoying to plug in because they're used to having sold for decades the pariah of HCI. They like the old Honeywell thermostat that just plugs in with the right colored brown, white, green wires that go to the standard Linux control board. And I mean, there's a lot of inertia in that side of the system. And we're all in it for the roller coaster ride right now to see like what changes fastest. You know, that's what the story with my friends that did the Gradient air conditioning startup, right? They're trying to like make an alternative system, but everybody's kind of pointing at the VAF, or the variable RF, the mini split units that are like obviously common in Korea and Singapore. But I mean, the one thing they do is at least they zone buildings, which we don't do in North America so well. So in more temperate places like DC, I would say like, you know, being able to turn on your kitchen and living room and your bedrooms off during the day is pretty valuable. But those systems still have their own issues. But from like a just practical implementation, they offer a little more opportunity to start being smarter. Then occupancy detection actually matters in your own house, right? You can make these systems automated, and occupancy detection has been one of the, you know, areas that like Zoltan and me and the Department of Energy, they've been trying to do research on how to do that better. And actually our sensors, one of the original uses was counting how many people are in the room behind me. Can be pretty valuable because you do that maybe. There was a lot of issue with CO2 sensors being used as sort of occupancy proxies or measuring, you know, for demand control ventilation. But actually knowing how many people can be useful for other reasons because they do other things besides breathe CO2 and lots of different interesting ways that then you can incorporate a little more. Well, it's easy to do data these days. And I think that's like all of the things, the smart controllers, the easy way to build multiple Raspberry Pi or Arduino devices that cost $10 each, right? I think to your sort of the distributed systems point, like it's not just distributed, it's the fact that with many systems comes much more data, but actually none of that matters because we're using thousands of times more data to run all the LLMs. And like, this is just a drop in the bucket, but we,
absolutely,
for some reason haven't really done it. We're still like locked in on these old school PLCs and the furnace guy that comes to your house when your furnace is broken and you're like over a barrel and you have no other option. It's just like, oh, give me another furnace. And oh yeah, I just have the standard thermostat. Oh, can I have a Nest? No, definitely not going to install the Nest.
Yeah, this is path dependency, right?
Yeah.
Yeah, absolutely.
Yeah.
So for both of you guys, like this is one of the things I struggle with, has to do with the evolution of components and systems. If you go back, 40, 45 years ago, and you get on your continuum and you do it like in 5-year increments. So what was being installed and serviced 45 years ago, 40 years ago, 35, right? Until you are to where you are today. Yeah. And you look back over that continuum of all the changes that have gone on. Mm-hmm. Ultimately, who suffers is actually the owner. It's the operators, because today, if you get a call from a system from the 40s or 45 years ago, what do you carry in your van if you're an HVAC contractor or service technician? Mm-hmm. Right? Yeah. So we have, and we've seen that. I mean, the furnaces for the most part are pretty standardized stuff, but even they've had changes, particularly in the modern ones, well, control boards and stuff like that, right? But mm-hmm. I struggle with the benefits of innovation and change on a continuum where the owner-occupier is left with the innovation.
Yeah, well,
and the creative.
Yeah, but they don't have any agency for most of that purchasing. No. Like nobody, there's no ads for, like, you don't turn the TV and watch your favorite sport and have an ad come on for like, which heat pump are you going to buy? It's like, it's not happening. And the money that's being spent in that domain is mostly being spent by the gas industry, pays Instagram influencers to go on and say heat pumps don't work in the cold. And they pay people to go on and say cooking with gas is the best way. Induction stoves don't work. So there's more money being spent to systematically undermine the change because they make more money with the path that exists.
Yeah, and then supply chains there.
Yeah. And I mean, the heat pump, the whole electrification and heat pumps, though, I think might be able to argue it's sort of that domino has fallen. People are like electrifying pretty quickly now, and there's a little less resistance than in the past. But I mean, I was interviewed by both the Washington Post and the New York Times for articles about whether heat pumps work, kind of. And in the end, they ended up writing an article about the lobbying industry to try and say that they don't, because you just have to read like a paper from 20 years ago to talk about how all the frost buildup, there's all kinds of cool material science about preventing frost from building up on evaporator units and stuff.
Yeah.
Lots of clever ways.
There is one issue though, right? Where like the build quality, I mean, I come from UK where my dog lived in a wooden house with a felt roof. Yeah, I'm paying them over $1 million for that here to live in it myself. So that's a problem for me.
Yeah.
Still not over it after 20 years, right? But the build quality of houses here is so poor. Like, the infiltration, exfiltration, the windows, you have to allow for that bad quality in the selection of the heat pump system, right?
Yeah. But at least for the retrofit scenario, as long as if someone is fortunate enough to replace their equipment not in the middle of the winter when it's broken, because nobody's carrying the heat pump on their truck.
Correct.
If they are, I mean, and a lot of my colleagues here, this is a very, we're in Princeton though, so people have resources. But the heat pump changeover right now, having the previous data of what the heating bills were makes it really easy to size the equipment and to even like realize that the previous equipment was oversized.
Yeah.
But the other really common thing that people do here is they already own a furnace, and if they want to electrify, you just put in a reversible heat pump into the coil, and then you still have your furnace, and that makes them happy that it's there, even though they probably will never run because we hardly have winter anymore anyway.
Actually, that's good. That retrofit. Now that would be a great retrofit program, right? What you just described.
Yeah. And it does exist. Yeah. I mean, I have a good friend that runs a HVAC company here, and he's very famous for exposing bad practices amongst a lot of HVAC technicians and installing air source and heat pump systems is because, I mean, an air source heat pump is just the standard air conditioner, that like the classic North American air conditioner sitting out on a pad outside with one part that costs like $15, like maybe a little more, maybe like $80 at United Refrigeration. You can buy a reversing valve. And obviously you can't just go put that into most machines, but that's the only difference.
But that's essentially the technology.
And an air conditioner. And they all go into a coil sitting into a ducted thing. But we're going to remind ourselves that we still hate air conditioning and ducts, though, at this moment.
That we need
Still like radiant. And if you have the ability to retrofit your house, though, it's a much more intense endeavor to rip all your floors up and put piping underneath all of them.
This is a
Adam, let's make a mental note to get Forrest's wife on the show. What's it like to be a partner of someone who wants
She's sitting there chain smoking. Do you know what I put up with?
No, you got to get the kids on. My 4 daughters, last night I did have the classic argument. We've had our first heat wave. We sort of jokingly say there was never spring. We only had summer because it was 90 degrees yesterday and the day before.
Wow.
But I did the classic old school thing, right? Although it's 90, our dew point's still 60. So overnight we get down to like 65. So I just open all the windows at night, close them in the morning, and then by the evening upstairs was 27 Celsius. So it wasn't even 80 degrees Fahrenheit.
Nice.
But my daughter was like used to sleeping in the colder temperatures. It was like, it's hot. Why don't you turn the air conditioning on? I'm like, oh, don't say that word.
Do you want to go to college?
Yeah.
Welcome
and
to
I was like, watch, we'll
North.
just turn on your ceiling fan. And then it's like, oh yeah, okay, now I'm fine.
So just so you know, Forrest, thank you for sharing that weather data from Iowa, because yesterday we had 40 centimeters of snow here.
Oh, geez. Yeah. No, we're all
Just had to bring that up, didn't you?
Yeah. No, next week everybody's like, winter's back. Here we're gonna have like highs in the 50s again of Fahrenheit. Yeah. This is the only thing about nerdy HVAC and heat people. I never know whether I should say Fahrenheit or Celsius, but we're like the only species that can do both, right?
Yeah. Depends where your judgment is. Well, I mean, why America? I love America, but for God's sake, get on the metric system. It is embarrassing.
Yesterday, my class student was like, "Oh, next week it's going to be 40," and I was like, "Oh wait, is it really hot or really cold? Because it's going to be either. Like, is it going to really be 40 already, or is it going to be 40 again? Which one are we saying?"
And yet, if you're going to buy a gun on the street, it's in millimeters, right?
Yeah,
if you're going to buy drugs, it's in kilograms.
Look, when you work with the U.S. military, which I used to do,
engines are in liters.
They all metric because they're sourcing all over the world, right?
Oh yeah. No, the SNL skit with George Washington doing the measurement systems. Everybody should watch that. It's the best. The whole joke on the Yeah.
See,
how many feet in a mile? 5,280. Don't you think that's a bit random, sir? No.
Absolutely not. Yeah, it's double disappointment for me because you guys see a liberator, I see a British officer who can't count properly. So look, we're coming up near the end. I've got a couple of questions that I do want to ask. One is the cube that you've got there. So are you going to commercialize that in any way? Have you got plans to?
No, we are. I mean, there's a website, C.H.A.O.S, without 2 S's.com. And we commercialized that in sort of a bootstrapping way. I did one VC-backed thing and didn't have very much fun because it turns out VCs get to pretend like they know everything, but they just have all the money. They don't have any brain.
Yeah.
So then we did another version where we just built them and sold them. So that's how Robert ended up with one. And right now it is literally kind of the build it out of your garage. One of my former researchers is putting them together in St. Louis, and then one of the former undergrads is in Austin, Texas, managing sort of the sales and documents and stuff. So they're on the website, them, right? And you can go on. We have 30 in stock. We have 30 with a little lead time because we got to assemble them. But yeah, we argue they're the only device that measures all of the 4 critical components of thermal comfort from a environmental variable. So you measure the airspeed and the radiant part, which are the least commonly measured. And then you have temperature and humidity, which is very easy to measure. So those 2 are harder a little bit. The radiant one is the one where we have all the know-how. Like that was what the research was, to develop the way to measure the radiant side, which I'll take a moment to not do the long-winded version. The short-winded comfort thing is half of the heat that you lose is photons exchanging with your surroundings, right? If you're in a 70-degree Fahrenheit, like a standard room, then roughly half of your heat that you experience is going by radiant. So it's important to measure that half, right, Robert?
Yeah. And how do we measure it today?
Yeah.
With a thermostat, which isn't even in the same location that you're at.
Exactly. Yeah. And then one of the more recent fun experiments I did was measuring in the room with these devices. I can measure from one side to the other. And if the mean radiant temperature changes by 2 degrees, one of the things I've been challenged by is trying to figure out how to tell that to people, because it sounds like a number. And so we all think of temperature, but this isn't, like, temperature is just wrong to start with. So I calculated more appropriately, if I go from one side of the room to the other, how much more heat do I lose on the colder side? And it turns out to be 10 to 20% of your metabolic rate. So that's like 10 to 20% of your body losing heat. So one of our goals in developing the sensor is to try and shift people into a mode that's not about temperature, but about understanding that your comfort has nothing to do with temperature metrics. Your comfort is just that your body is sadly a little inefficient. So when you think and use your muscles, it generates heat. And if you don't get rid of that heat, you feel hot. And if you get rid of too much of that heat, you feel cold. And so it's really just a managing of the heat flux leaving your body kind of framework. And so if you think of it as like, you get 10% more heat over here, 10% less, I like talking about it in that percentage way. That's my new strategy, because trying to find an intuitive way to discuss it that's not temperature, I think, is really important, to shift away from the cool all the air in a box and tell people that the 50% humidity and 70 degrees is what we all need, when it's not. Because if I put a fan on you under those conditions, you will be very cold.
Yeah. All right. Well, that's my wrap-up question. What about you, Robert? I like that.
Forrest, I'm going to get you to discuss the renovation of your house as a couple. There's so many questions I could ask you, but one of the things that, because you and I have been talking about our renovations for the last couple of years, right?
Yeah.
And our spouses, are part of that journey.
Yeah.
So for those kids that are in school, at some point you're going to end up in probably a home, an apartment, condo, whatever, and you're going to want to renovate, and there's going to be somebody in your life that's important to you. So what are your words of advice for managing a massive renovation where your home becomes a laboratory and still maintain your relationship?
Don't be a dictator. Definitely. And number one, and at the beginning of the project, always start with excavation, because letting your kids drive a backhoe, that's a life-changing event. Luckily for me, I had to excavate the basement in order to remove that giant furnace monstrosity, because my basement did not have like an exit to the outside. So I dug like a little walkout thing. That was step one. So yeah, that's kind of silly, but and I guess that just speaks to the longer part of it, is just, if you're not a dictator, you also at the same time have to make it fun. And it was a lot of fun. Even like running the wood stove in the winter, like, it was kind of reminded me of being a kid. You got to get up early to put more wood on the fire, and in the house, the coldest it got was 55 degrees, like on a 10-degree Fahrenheit day, I think. And it's not that bad. I mean, and I think that's one of the things we can also just reflect on, the fact that air conditioning has also kind of made us wimps. And I don't want to call it austerity, because it's not austere. It's like, austerity has become kind of a bad word. There are things we should do if you actually think climate change is real that are like austerity. Like, you should work harder to bike places further, and you should not be so dependent on artificial energy. But the climate one is not so austere. It's actually kind of fun. And I think most of us, that like the outdoors, like I know Robert does, like, they're like, being outside and having variable temperatures is the way our species and every species has evolved. And this sort of fake idea that we should be in one temperature all the time is also just, I think we all would agree that it's not a healthy thing from a psychological standpoint either.
No.
So I think there's the whole thing about like putting my kids through the craziness was, the craziness of the build and the mess is fun. You can make that fun. Man, did they make a huge jungle gym out of the upstairs when all the studs were open and they could climb up to the top of the thing on the wood, on the fire blocking. And yeah, there's tons of moments like that. And then with the spouse, right, it was like making sure you help give like enough of a kitchen. I built so many makeshift kitchens in different places while we were redoing the kitchen, right? And then trying to be helpful. It's like, oh, screw this shelf in here. You want another shelf, honey? You need another shelf here? Because the good thing about renovation is like, you can screw anything into anything. It's like, okay, we're in the middle, like whatever. Put a 2x12 here. Okay. Yeah. It's, being a little adaptive in the middle, comes across as being helpful, even though you're just kind of interim problem solving. But yeah.
Yeah. And there's a lesson in there, and that is that knowing who you are, if you don't like chaos, for example, and then don't even put a hammer into the first drywall. Like, don't start ripping shit apart, because you're gonna
exactly. I mean, you have to have a little bit of a plan. It's more planning than I've ever done in my life. I'm pretty famous for not planning very much. But I did the house. I had to make a few drawings, and like.
Well, that's like you're telling me about when you were going to deliver your thermostat, or what was it? Your manifesto, your manifesto.
Yeah.
Right. So just so the audience knows, like, I mean, I think you were in Zurich when you did it, I think. And anyways, we just got this email, from Forrest. Tomorrow I'm going to give my therm manifesto. And you're welcome to listen to it.
With all these everybody thought it was going to be more grand, I think, because I called it a manifesto. But really, I just wanted to get a bunch of people in a room to back me up and be like, "Can we just say air conditioning is dumb?" Like all of us.
They probably expected a Chairman Mao, like.
It was a little, But I did a better job at MIT last week. I gave like the manifesto lecture, and I actually made more of like a list, which I need to like. I should publish the list I put at the end. It's pretty nuts and bolts kind of thing.
If you want to send that to us, we'll happily put it in the show notes. Actually, that'd be.
I'll send the Therm Manifesto, the 10-point Therm Manifesto. Number 1 is don't be dumb, and number 10 is you can do anything. And then in the middle, there's some smart stuff.
All right, but that's a good way to wrap up then. So listen, man, thanks for coming on. That was excellent. I really enjoyed that talk.
Super fun, and I appreciate everything you guys do. I mean, it's like the best.
Thanks, Forrest.
Thank you, man. That's high praise. I appreciate that.
The Edifice Complex will continue in just a moment.
Are you passionate about the built environment? Do you want to learn from the industry's most inspiring, intelligent, and accomplished professionals? Then the companion to this podcast, Wisdom of the Property Crowd, is just the book for you. From Edifice Complex podcast interviews, this book distills the critical thinking, insight, and ideas of some of the property industry's most accomplished and respected practitioners. Each chapter is a synopsis of an hour-plus interview, capturing the takeaways and insights, including diagrams and images, to help explain concepts and ideas. There's also a brief bio about the interviewee and a QR code linked to the podcast episode for those that want to explore further. These are the mentors you wish you had in college. Wisdom of the Property Crowd by Adam Muggleton. Available on Amazon worldwide.
And now, back to the show.
Shout out to Forrest. Thanks for coming on. Clearly there's a brain there I love his journey, right? I mean, he grows up on a farm. He's a farm boy, fixing shit, breaking things, right? And then takes his brain on a journey that's, academic, but then he's back doing his stuff. And so, like, in terms of the bookends, of sort of the practical world to the academic world, and then marrying those two worlds together, and then using that to challenge thought in terms of architecture and buildings and energy. There are very few people like him around in the world.
He's that rare beast where he's a super academic, but he's also a super good communicator.
Yeah.
Right? He's got a personality, and he could have a YouTube channel, and he's the sort of guy that should be in university, rah-rahing people and getting them excited, because he can actually do it, right?
Yeah.
I was really impressed with him. He was like the super cool prof, you know what I mean?
Well, and you can tell, like, when you're conversing with him, he makes a concerted effort not to get into the technical jargon and shit. Like, if you want, he'll go that direction. Like, for sure. But when he's trying to get a message across, like, you can see he's actually working to use words and to give analogies, metaphors, so that people can understand.
Yeah.
That's a rare gift.
It is. And look, he's all right. If you got his job, you're a prof at Princeton, that's pretty sweet, right? No. But he's not sitting on that. He's making things, he's changing things, he's writing, he's doing more.
Oh, yeah.
Than most profs do.
Well, yeah, and what I mean, when you get talking with Forrest, I mean, you could talk for days, literally, with the guy. I mean, if you went to go visit him, and hopefully someday, that'd be a great, actually, if we ever take anybody out there wants to sponsor Adam and I to go do on-site interviews with people, I would try to arrange to go see Princeton University, because they have a network system. They use a lot of hydronics, radiant heating, radiant cooling. And so where I was going with this is that Forrest is in there with the staff. Like, he's in there with the maintenance crews, the engineers.
He's what I call a workshop prof. He'll workshop something. Do you know what I mean?
Oh, yeah.
That's not quite right. Let's fiddle with it. You know?
Yeah. So,
he's great. If he could partner up with someone with huge amounts of capital, he could actually do something, right? The problem with people like Forrest is they sort of like, they're kept in a box.
Yeah.
Right. But let's face it, you need gobs of capital to actually change things, right? It's like that firm Katana who were going to change construction failed, right? They didn't have enough capital when they were still trying to do what everyone was always doing. But if you do want to change something, it's like the Elon Musk thing, right? Yeah, Tesla lost money for ages, and he just ate that up and went long enough and survived long enough to turn it around. But how much capital did Tesla consume for the first 10 years of his life, right? It was just a sinkhole for money. Yeah. But that's what it took to change an industry. Yeah. So if we talk about changing how we do building services in buildings, it's going to need that level of commitment. That black hole of capital has to be there so that someone can eat through it to the point where you can get some scale.
Well, and think about this, Adam, like with Elon and Tesla, maybe there was like six brands of automobiles that did not want him to succeed.
Yeah.
Right? In the HVAC industry,
everybody doesn't want to succeed.
It's the scale is so big, that
and it's you against the whole world, basically, if you're trying to change it, right?
Absolutely. You think about, have you ever seen those diagrams where you look at brand names and who owns the brand names? The consolidation that's gone on over the last 20 years.
Everything goes up to about 6 dudes in Zurich, right?
Right? None of them, there's no interest in them to change anything, because it's
working just fine for them. Yeah.
It is. It's Warren Buffett's toll bridge. It's cha-ching, cha-ching, cha-ching. It's a cash register that just dinging every 30 seconds. There's another $1 million in the bank account. So they don't want change.
No.
Right. So for people who are listening to this industry, like, it's one thing to be able to sit here and we do a very good job of philosophizing.
Yeah. But look, money, you need grit, backbone, and gobs of money to change anything.
Yeah.
Real, right?
Yeah. But you guys had a good discussion about where change comes and how easy it is actually for people to have access to that change.
Yeah.
And so maybe that is the solution, that these big brand names that just dominate the marketplace, that aren't interested in hearing what the Forrest Meggers of the world have to say, that it will be changed at a much more localized.
The greatest power known to man and God, right, apart from E equals MC squared, is consumer disobedience.
Yeah.
BlackBerry, if you'd have told BlackBerry 2 months before the iPhone was launched that they were going down to zero in 2 years, they'd have laughed you out of the room.
Yeah.
Right. But in the end, the consumers went, you know what? You're not good enough.
We're done.
Goodbye.
Yeah.
Right.
Yeah.
That does happen, right?
Yeah.
So that's what it would take. It would take a occupier owner revolt against what's going on now to change things, right?
Yeah.
If people have an option to buy a house that's thermally efficient with, radiant heating and cooling and DOAS, and word gets around, right? Then all of a sudden the shitty build doesn't work anymore, right? But what does it take to do that? Is what Katana were trying to do, right? You've got to manufacture and sell houses at a loss probably for years before you can get that critical mass that you can then challenge.
Yeah.
Right. This is the business aspect of it, right?
Yeah.
Why did Google succeed? Because they went public early and basically had the ability to literally print money by issuing shares.
Yeah.
And then 5 years later, they're Google, right? So, that's what it takes. This is the business side of things people don't talk about. But that's what it takes, right? This is why there's venture capital funds and blah, 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 and blah, blah, blah. If you could find the venture capital equivalent of Forrest and put them together, that's something that could change something, right? Like a nerd with money meets the nerd with the nerds.
Yeah.
It's like freaking life-changing stuff, right?
Yeah.
But it's
and maybe, because I do know, like, for example, Train lately have made individuals who are on the hydronic side be more vocal. And we're starting to see like Christoph Irwin the other day, he's our past member of our alumni, was doing interviews with people who are on hydronics. And we've got a couple of gigs coming up, speaking gigs with people from those organizations. So we are starting to see people talk about hydronics. And I think, but that came from the air to water marketplace. That wasn't because all of a sudden people woke up and said, well, we should be talking about hydronics. It's because the water part of it, as Forrest pointed out, I mean, it is the transmission that can move energy way more efficiently and effectively than air can. So
I used to have a slide, this is years ago, right? A picture of a pipe, and it was like how many kilowatts of cooling could it transmit versus the equivalent duct.
Right. Yeah.
And it was I used to put it out and people used to go, what, really? Because look, when I came from the UK, all the office systems are hydronic because there, the way space is let, you can only get rent for the net space, not the gross. In North America, you let the gross space. So you can have a big riser, doesn't matter, tenant's still paying for it. In the UK, that riser has to be as small as possible because you can't charge the tenant for that.
Right.
You wind up with really tight risers, radiant heating and cooling, and like the only ductwork is like the minimum fresh air requirement.
Which is what it should be.
Yeah. Now that's a money-driven thing, right? Somehow, when I go to America and I think, I went to Arab. We were in a high-rise office, and there was a massive air handling unit room on every floor. And I'm thinking, how the hell does a landlord make money? But it turns out he does because he charges them the same rent for that AHU room as he does for the office.
Right. Yeah.
It's fucking bonkers. Yeah, but somehow they got away with that in North America and no one changed it or challenged it, right? If I was a landlord and I really wanted to beat the market, I would just say, don't worry, I'm going to give you, optimized floor plates. You're only going to pay me for the net, but I'm going to charge you a bit more for it, right?
So again, like for our listeners, North America represents, like I said, 5% of the global population. The rest of the world really doesn't give a rat's ass about us. Like we're so small.
Not at all.
But we carry pretty big egos on our shoulders and we're pounding our chest about how great we are. I gotta tell you, man, when you travel as much as you and I have, and we've been all over the world and you get to see other cultures, we are so far behind on so many things.
I have to say that, look, I enjoy living in North America, don't get me wrong, but I'd say the rest of the world is pretty much a generation ahead in terms of building services and building construction.
Yeah.
And that's hard to hear. Most Americans laugh at me when I say that, and they don't believe a word of it.
Yeah.
But I've seen it, and it is better. Right?
Yeah, even safety protocols. When we were in, just came back from Australia, we were there for 2 months. Like every building going up is encased.
Yeah.
In a safety mesh.
And the public realm are protected, right? And there's,
totally, completely different. Like here in Calgary, like there's high rises here, and you drive by and no safety nets, or they've got ropes. It's like
I dread it. Look,
really bad.
Construction sites in Canada are so unsafe. Look, in the UK, if someone dies on your site, someone is going to jail for that.
Yeah.
That is a real fucking problem. And your job gets shut down for a week while the health inspectors come and investigate it. Yeah. So it is an utter disaster if there's a real death on site.
Like people need to understand, like when you go, like for example, if you go anywhere sort of in Southeast Asia, where they're still using bamboo as shoring for foundations, right? Or you go to Mexico and the same thing. And Mexico is kind of interesting because it's got 1 foot on the dock and 1 foot on the boat. In terms of job site safety and construction practices, right? But you can be walking down the street and you can see like old school stuff and then modern construction sites. Asia, Southeast Asia, depending on the wealth of the city, I mean, you would never let anybody on those job sites that you loved because there's a good chance they're not going to come home at night. Well, even here in Canada, like I got to tell you, like, I don't know where the safety supervisors are or where the protocols are, but they're not like in other more modern cities where
the consequences are there. I spent my first couple of years in Canada thinking, holy shit, what's going on here? You know, it's like they were so unsafe, the sites. Absolutely terrible. And there were deaths on some big jobs, right?
Yeah.
And there was no prosecution, which fucking astounded me, quite frankly.
Yeah.
It was like slapping them, don't do that again, here's a fine, carry on. You know, some poor guy's fucking not going home at night. Oh, well, these things happen.
Yeah. So for our listeners, you know, we kind of got off. I mean, in terms of what our purpose of our podcast here is all about, I mean, Forrest just hits all of the cylinders. He's got all the cylinders firing. You know, in terms of things that, like getting hit, like you said earlier, I know people caught it, but, you know, he was on his bike and got hit. You know, changed his life, right? But it also, you know, took advantage of that and, you know, did some really cool things. But, you know, so there's a guy who's had adversity. He's hands-on. He's academic. He's just, you know, his wheels are always cranking. And so if you're, you know, in school right now and you're looking for inspiration, you know, follow the Forrest Meggers of the world. And because the guy he's on a path that we really believe in. And then the second thing is sort of what this tail end of this discussion is that, look at, when you're in North America, you know, you have to open up your eyes. Like, this industry is dominated by a handful of manufacturers whose agenda is just to keep the machine running, and it needs to be challenged because the rest of the world operates in a completely different way, and they have much better buildings, much better environments. The energy, the awareness of energy is way at a different level than it is here. So you know, yeah, it's a great place to be, no doubt about it. I'm happy to be a Canadian. I'm happy to live here. But I got like you travel and.
Yeah, I mean, look, the North American lifestyle is one of the reasons we emigrate here. It's nice. It's lots of space. You know, roads are big, lots of trees. It's awesome, right? Yeah. But then also, the built environment is another part of that, right? And I find I'm consistently horrified by it. It's just no two ways about it. But to my final thoughts are that there's something that's never explained to you when you're young. It's all very well doing all the right things. You do need an element of luck in your life, right? Mm-hmm. So in North America, the class system revolves around where you go to university. I'm sorry, guys, that's just the fact of life. That logo on your CV or your resume matters. But knowing what I know now, I would select based on professors, right? If you stumbled into Princeton, who stumbles into Princeton? You work your ass off to get into Princeton, right? But you got Forrest there. That's like lucky. Yeah. Because he's going to explain things to you and give you a perspective you wouldn't normally have. And it's the same when you go into the workforce. If you're lucky, you'll get a grumpy old mentor who will work you like hard and drive you nuts. But at the end of it, you will come out way better, right? Yeah. This is the luck you need. So you need to be clever. You need to make good decisions, but you also need a bit of luck. And I'll tell you, if you're in Forrest class, I'm saying you're lucky. You've made it.
Yeah, for sure.
Yeah. Anyway, we're lucky, right?
Absolutely. Oh my God.
All right, man. I'll see you on the next one.
All right, Adam. Cheers, man.
Take care.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. See you next time.